So first in the last video we have seen how to do basically what is LPP problem, then how to little bit interpret the sensitivity report we are getting. So if you remember, Z is your objective function, values are your optimal solution. What we have done in the last video is binding constraints are 1 and 4, non-binding constraints are 2 and 3. How we will recognize them? When the left hand side and right hand side are the same, which means there is no slack and no surplus. That means they are binding constraints. When there is a slack or surplus, then they are non-binding constraints. One more idea to identify the binding constraints is the binding constraints have non-zero shadow price. They are having zero as a shadow price. They are non-binding constraints. Then in the sensitivity report, we have, see, this part will not be given by this Excel. This we have generated. How did we generate? The objective coefficient, which is the number of the coefficient values. This is the units, number of units it can increase. So this 50 plus 75 gave you the upper limit 57.5. And the same, the decrease gave you a lower limit. Similarly for 60, similarly for 55. Upon these limits, we have understood what happens. So see, we have changed the values of C from 50 and 35. When it is within the range, the optimal solution did not change. 0, 70, 30, 0, 70, 30. When it is beyond range, the optimal solution has changed. Now the second part is, here we have changed only one value, only for one variable. What happens if we change it for two variables? So then we have to use the 100% rule. That is what we have stopped in the last video. What is the 100% rule? Suppose, let me first copy the same problem. Again, I'm changing it to 0, 0, 0. The same 50, 60, and 55. Initial coefficient 50, 60, 55. Whenever you copy it, once check where your sum product, where it is taking, is it taking the correct value? Here it is taking the wrong values. So just change it. It should be 72. Just drag it. Then your coefficients are 100, 300, 250, and 60. So this is your initial case. Here we are checking. What is the case we are checking? When two coefficients are altered, then what happens and how to see? Initially, we have done it for only C. Now let us do for both B and C. B and C. So here theory says if we are doing it for two or more than one coefficient, it should satisfy a rule called as 100% rule. The rule is like this: sigma of proposed change divided by allowed change is less than or equal to 100. So what is the sigma allowed proposed? And sigma is nothing but summation. Summation for, suppose for B, say for B, then say for C. What is the proposed change? Then what is the allowed change? So right now, maybe my new B is, here the B is 60. Suppose my new B, I am increasing it by 5 units, 65. Okay. Suppose my new C, I am decreasing it by 5 units, 50. Okay. So what is the proposed change? Plus 5. What am I doing? Plus 5. Well, go back to sensitivity report. For B upper limit is infinity. So the allowed change, how much is the allowed change? Infinity is the allowed change. Why I am checking only the upper limit? Because here I am increasing it in a positive way. So I will check it in the increase side. The increasing value is allowable. This is the units. This is not the boundary, right? So this allowed change is the units, not the boundary. So how much is allowed? Infinity is allowed. No. Type infinity. For C, but what I am doing for C? C I am decreasing. B increasing, C decreasing. So C is decreased by 5 units. So the proposed change is 5. These are units. Proposed change and allowed change are units of change, not the range, not the value. See, B is 65, but the units are 5 units. So similarly, this is the increase. That is why I'm checking in the allowable increase. Allowable increase, 1E means it is very big number. You can take it as infinity. Similarly, for C, the proposed change is not 5, minus 5. Because from 55, it is going to 50. So it is a decrease by 5. Now, where we have to see in the allowed change? We have to see the allowable decrease. So allowable decrease for C is 15 units. This is boundary. This is units. So the units are 15. Now, what is the 100% rule saying? It says that 5 divided by infinity, right? This value divided by infinity plus, see the formula bar, plus minus 5 divided by 15. This is a proposed change upon proposed. This is also negative, no? Both are negative. This is also minus 15, no? So that minus and this minus both will get cancelled out. You're getting? Both are, this is also minus 15, right?
It could have been interpreted in a different way as well. Like we wrote, C is getting decreased. By how much quantity? 5 could have.
Yeah, same way.
With the
You
sign.
can take it as units. But why I'm writing here minus is so that we check in the correct part. We check it in the decrease part or increase part. So we don't confuse there. That's why I'm putting it minus. You can take it as absolute values also. That is also fine. So this value, whatever this sum is, this should be less than or equal to 100%, which is nothing but what? 100% means 1. So how we do it? What is 5 by infinity? 1 by infinity is 0. 0 plus. What is 5 by 15? We'll just do it. Just put equal to, then 0, because one by infinity is 0 plus 5 by 15, which is 0.33, which is 33%. So this is obviously less than 100%. Just change it into percentage. 33% is less than or equal to 100%. So 100% rule is satisfied. Now this is satisfied means what happens? Coefficient changed by these values, optimal solution remains same. Okay. So for one coefficient, if it is changing, we will only check about the allowable increase and allowable decrease. But if more than one coefficients are changing, when 2 or more coefficients are being altered, then we have to check the 100% rule. So that 100% rule is summation sigma proposed change by allowable change for each coefficient. This sum should be less than or equal to 100%, which is nothing but 1. So since here this rule is being satisfied, now let us check it. We are both in the way understanding the theory side. In the other side, we are parallelly also doing the practice. So let us check if it's really happening or not. Data, solver, always reset this so that you don't get any enter wrong value. Z is your objective function, maximize it, changing these 3 values. These are your constraints.
But I haven't changed the coefficients now. Need to change.
I'll change the coefficients. Add it. Then these two. This is greater than equal to. These are the constraints. Since you have added it, since I have not yet changed these coefficients, let me just close it. So B is 65, C is 50. Just go back to your solver. So usually it remembers your previous entry. Just check it, even then it is better. G71, B72, this is the same. F75, this is the same. It did not take one more constraint, second constraint. Let us add these two, then less than, then these two, add, cancel. So we have given everything, simplex, solve. So see, again 0, 70, 30. What do you have said? Optimal solution remains same. So that is the interpretation from sensitivity. So we get three reports: answer, sensitivity, limits. We are not concerned with answers, we are not concerned with limits. So we are concerned with sensitivity report. In sensitivity report, we have two tables. In the upper table, one we are looking at is the when coefficients are changed. Either they are increased or decreased. When only one coefficient is changed, we have understood what will happen to optimal solution. If it is within this limit, upper and lower limit, optimal solution will not change. If it is not, optimal solution will change. Optimal solution is different from objective function. Objective function will definitely change. So here for every case, we have solved it. For every case, we have seen if it is changing or not. In exam or in any other place, we might not have time or there may be so many constraints, we may not be able to copy paste and solve it. That's why if we are able to interpret from sensitivity report, our work will become easy. In the second part, we have understood if more than one constraint is being changed, one rule which is called as 100% rule has to be satisfied. If it is satisfied, the same thing, optimal solution remains same. If it is not satisfied, optimal solution will change. Then the second interpretation from the above table. So if you see these final values, we have understood. The objective coefficient we have understood. Allowable increase we have understood. Allowable decrease we have understood. There is one more column which is called as reduced cost. So what is reduced cost? So if you see the reduced cost values, it is minus 7.5, 0 and 0. Reduced cost says that if this value, that is A's optimal solution, if it becomes 1 from 0, if this value, the optimal solution, if it is becoming 1, then your Z, it is reducing by minus 7.5. It reduces by minus 7.5 means this A, it is better to not give any value to A so that you achieve Z better. Why is it saying? Because it has to satisfy the constraints. Due to these constraints, it is not giving any value to A. If at all you give any value to A, at least one value, A is equal to 1 unit you give, then the Z will reduce. Why will it reduce? Because there is a negative sign. If there is no negative sign, it will increase. That is the meaning, that's all. It is only for when there is a negative values we interpret. Usually that is not asked in this part.
What if there had been a positive value?
नहीं वो होता ही नहीं ना कंप्यूटर तो ऑप्टिमल वैल्यू देता अपने को
So with respect to reduced cost, what we have understood is assume these A, B, C are three machines. There are three machines. As the owner, you want to use all the three machines. But from this, what we are interpreting is if at all A is used, means if you are giving 1 unit to A, your Z will reduce by minus 7.5, which is why it is better not to give it. So the name reduced cost. So from the above table, we have seen two constraints, one with respect to the coefficients, the other with the reduced cost. With respect to coefficients, we have seen what happens if one variable is changed, one variable coefficient is changed. What happens if two are changed? If one are changed, you just write these upper and lower limits. If it is within the limit, optimal solution remains the same, else optimal solution will change. If two are changing, check for the 100% rule. Then in the below table, with respect sensitivity report, we have seen that what will happen to the objective function, which is Z, when the right hand side of the constraints are altered. Here also, if you see the same, look at the columns, cell, name, final value. Final value is nothing but your LHS, shadow price, constraint right hand side, allowable increase and allowable decrease. The same here also, upper limit, lower limit. In the previous video, what I have said is a unit increase. So a unit increase in RHS of a binding constraint increases the Z value by shadow price of that constraint. This is for 1 unit, but you have to have the limit until how many units you can increase. So if you see for the first constraint, shadow price is 60, the right hand side is 100. What is the allowable increase? 10 units. So what is the upper limit? 110. What is the allowable decrease? 6.67. So what is the lower limit? It will be 92.33. Right? Then 93.33. Okay, 93.33. Yeah. So the second part here also same, it is allowable increase is infinity. Then here allowable decrease is 270. Here the same way 250 plus 270. Then this is negative infinity. Then for here 60, allowable increase 40, so 100. Here it is 0. So for 1 unit, the Z value is increasing by 60. For 2 units, 60 into 2. For 3 units, 60 into 3. But that increase should lie within this boundary. Only then the Z value, see, above table is affecting only the optimal solution. Optimal solution is affected by the above table. But below table affects the Z value. So how is it affecting the Z value? The same case, allowable increase, allowable decrease. From that you get the upper and lower limit. So for every unit increase in the right hand side of the constraint, Z value increases by 60. So if you are decreasing the constraint, what happens? Z value decreases by the shadow price. So for that we have done already one problem. In the previous video itself, we have done it. Here we have increased the right hand side by 101. Is 101 within the limit?
Yeah.
Since because it is ranging from 110 to 93.3. So 101 is in the limit. So that increase of 1 unit, what is the shadow price? 60. So that 60 has been increased here. That is what we have seen.
For binding.
For binding constraint. If it is, even if you do it for non-binding constraint, shadow price is 0.
No change.
So no change. So it up. So this is one way to see if the constraint is binding or non-binding. If the shadow price is 0, it is a non-binding constraint. Shadow price is non-zero. This means it is a binding constraint. Now let us do it for constraint 4. We just do one more example so that this part is also clear. So here we'll do one increase and one decrease. Both we'll do. So this range is 0 to 100. One we'll do within the range, one we'll do out of the range. So first things first, copy the entire model. Now commit here. So this we are doing it for RHS.
Within the range.
Okay, first we'll do within the range. So these are the same values. Let us change 0, 0, 0. This has become 0, which means it is correct formula. Here it is formula is wrong. Change these values to 85. 85. Now just drag it. Now the old RHS for constraint 4 is 60. Then the new RHS for constraint 4,
61, 59.
let us see the limit. For 60, 0 to 100. We are doing it for within the range. So let us do it for 51. So the new constraint is 51.
Do it for 65 also.
Okay, any value.
Because if you increase it, then you can see the reduced figure.
Okay, let
What
us
I
see the
want to see
increased
is-
value.
No, what I want to see is like if we decrease and two negatives, will it make it to positive?
Okay, you want to decrease. Okay, we'll go to 51 itself. The initial value 51. So it is 60.
Because for increase, we
51.
know that it will decrease, but with two,
So this is
if they
51.
decrease, will it? There should be decrease of minus.
So what is our learning? So our learning is here. Let's paste it again. We have learned a unit increase in RHS of a binding constraint increases that value by shadow price of that constraint. Instead of increase, replace it with decrease. A unit decrease in RHS of a binding constraint decreases the Z value by shadow price of that constraint. Before that, what we have to check if it is within the limits. It should be within the limit. So number one, what is the new RHS? 51. So is it in the limit 0 to 100? Yes. If you have not formed the limit, just check the allowable increase and allowable decrease. Since it is a decrease of 60 units. I am decreasing by 9 units. So it is allowed, first point. Now it has decreased by 9 units. So what should happen to Z? Z decrease by 9 into shadow price. That should happen theoretically from what we are learning. So what was the old Z? Z old. See the 5850. So old Z is 5850. So Z new theoretically what should it become? Is equal to 5850 minus how many units? 9 units into what is the shadow price? Minus 2.5. So minus of minus 2.5. Minus of minus. So shadow price will actually increase. Right? Sheet 9. Now let me just change the value. Sheet 9 is not necessary. Okay. 9 into 2.5. So this is our formula. So this should be the new Z new.
Yes.
So what actually happened? It has increased. Why? Why? Because minus 9 into minus 2.5. Minus of minus. So it become plus. Now let us check if it is actually following the theory. Data, solver, reset. Okay. Then your objective function. If your window is just objecting the screen, then just press this button. So you can select your Z, then again click it back, your window will appear. Then maximize, changing these three variables, constraints. These two are less than or equal to, then these two, add the next two constraints. Here it is greater than or equal to those values, add, cancel, simplex, solve. It is solved 5872.5. Correct. So our theory is correct in the first part. So we have done in the first part. Now let us see here what did we do? We have reduced it by 9 units. Now the same way, again go to the first part. Now let us increase it, but we'll increase it out of the boundary. The same, paste 0 0 0. Here it is 97. 9 9, then just drag it. This part. Now same we do for fourth constraint. 60, limits are 0 to 100. We'll increase it to 120. Okay, so old RHS constraint 4 is 60, new is 120. So I've increased it to 120. As per the theory, what should happen? But the theory, it should, these optimal values have changed and this Z value is what we are speaking, increasing or decreasing. If it is out, there is no specific rule that follow. Which means we cannot say what happens. For that case, we need to rerun the model again. There is no theoretical way to understand what happened. Here we have said the Z value will decrease by 9 times the shadow price. But when it is beyond the limit, we don't know what will happen. In such case, what we should do? Rerun the entire model. This is the solution. We have to rerun the entire model. Rerun means we have to, as we are checking it, we are checking the models, right? For every case. That is nothing but rerunning the model. Every time we are generating the optimal solutions. Every time when you're generating optimal solution, which means you are rerunning the model.
Got it.
That is the case.
So we are rerunning here and checking what happens.
We don't check anything here. There is nothing to prove.
Okay, no case.
Nothing to prove here.
Case.
Once if it is beyond the allowable increase or decrease,
Business.
which means theory doesn't know what happens.
Random.
Why are we trying to interpret the sensitivity report? So that when there are more constraints, 20 to 30 constraints and more variables, we can't just every time copy paste and run the model as we are running here. In that case, for our easy way of doing access, we are interpreting from the sensitivity report. So if this C value is going above the bounds of the permissible limit, then you definitely have to rerun and check what happens. There is no theory to prove here. Just for our sake of understanding, we'll just solve this also and see what's happening. There is no theory to prove as such. What if at all 120 like this happens, like this, we have to rerun the model again. Then let us add. See, solver could not find a feasible solution.
So what you did now is called rerun.
So we are rerun. What we have, see, every time we are running the model. What is our model? This is our initial model. This is our first model.
Every case we are rerunning it.
Every case, theoretically, interpretation exists. What will happen if at all you are doing these values, those values and all. Every case, there are theoretical values. We are running them and checking if the theory is holding true or not. That we have verified.
The theoretical values, we are just confirming.
We are just confirming it. So if we already know the theoretical value, we need not do all this. We need not do all these calculations. We'll just go to sensitivity report. We'll identify if it is in the limit. Then we'll directly jump up, directly get the value, whatever the value is. Suppose here if we have seen the C value, it has been reduced by 9 units. What we'll directly do is, like here we have applied a formula. L83 is 5850. 5850 minus, because C reduced, minus 9. Why 9? It is reduced by 9 units into minus 2.5. What is 2.5? Minus 2.5 shadow price for that particular constraint. So that we within 2 minutes we will know what will happen to Z. But this we got after solving. Without solving itself, we can say, see, exactly this value matched. Before itself we have calculated. So that is the use of this case.
Okay, for taking the values.
So hope you have understood this part. In the next video, we'll see the next part.